Thanks for being here today and attending Sun Horizon workshop. Today we will discuss about the heat pump role in today's Horizon Europe context and what we are doing in Sun Horizon. Here we have an overview of the agenda today. So we will start with Andrea from Cartif, who will present us the 5 technology packages that we have in Sun Horizon, thus to provide you an overview of all the technologies involved in the project. Then we will proceed with a policy overview given by my colleague Josephine. And then we will start, let's say, a more specific section in a more addressed to the heat pump technologies deployed in Sun Horizon project. So we will start with a presentation provided by Sebastien from BDR Termea. We will proceed with Norbert from Boostit and Bashir from Fahrenheit. We will conclude the presentation with Joseph from Veolia, who will present us the ESCO's perspective. And then we will have a final panel discussion of around 20 minutes at the end. The ground rules of these meetings are that, as you see, we will have a round of presentation and we are keeping all the questions at the end. So please, whenever you have a question for the panel, please submit your queries in the Q&A chat, and all your questions will be addressed at the end. When you send your message, please remember to write the name of the speaker you want to refer to. Before officially start with the first presentation, I would like to briefly mention the Sun Horizon survey. So in the framework of Sun Horizon, we are now sharing a survey with European stakeholders, thus to collect information from heat pump and solar stakeholders. We want to receive feedback on the regulatory and on technical framework regarding standardization. And we will also like to receive some feedback on potential customer and possible limitation to uptake the market, both for the heat pumps and the solar thermal technologies involved in the project. Here there is the link of the survey. In 2 days, you will receive an email with all the presentations you will see today, and you will also have the link of the survey. So if you can dedicate around 15 minutes to fill it in, this would be very much appreciated from the entire consortium. So this is it. I think we can now officially start with the first presentation. So I ask Andrea to please share her screen. And the floor is yours, Andrea.
Thank you. Okay. So, good morning all. My name is Andrea Gabaldon from Cartif, a technology center that is located in Valladolid. And for today's presentation, I would like to briefly introduce you the Sun Horizon project, which is coordinated by Reina Consulting. And I would like to present you the technologies that are going to be implemented, how the technologies are connected to each other, forming 5 innovative technology packages. As a start, I would like to mention, wait a second. Okay, now. As a start, I would like to mention that as stated in the EU strategy on heating and cooling, large-scale demonstration projects are needed to help reduce technical and market barriers. And that is exactly what Sun Horizon does, thanks to the implementation of the 5 innovative technology packages in 8 demonstration sites, which finally allows to provide heating and cooling with lower emissions, lower energy bills, and lower fossil fuel dependency. These 5 innovative technology packages are meant to reach a technology readiness level of 7. And they are properly managed and assisted by a cloud-based functional monitoring platform with different services, such as demand prediction, proactive and predictive maintenance tools, or a hybrid advanced controller, which is also supported by the smart user interface. So finally, all the services and the innovative solutions that are applied, maximizes the solar exploitation and gives the manufacturer inputs to new installation design and an improvement of their technologies and maintenance plans. The project has a very industry-driven consortium. It has 5 top-level academic polytechnic institutions with 12 industrial partners and 4 associations and stakeholders acting as a demo site. Specifically, we have 8 demo sites in different, covering a wide overview of the climate conditions in Europe. We have demo sites in Madrid, Piera, Sant Cugat. We have in Verbiers in Belgium. Then in Germany, we have 2 in Nuremberg and Berlin. And then in Latvia, we have Riga demo site. And also it covers different energy market solutions because we have single houses and apartment blocks, as well as public buildings, sports centers, and a swimming pool. The demo site, the needs of these demo sites are supplied with different combination of technologies that I'm going to present now. We have heat pump solutions that you will know more about them later. But for instance, we have Fahrenheit unit, which is an adsorption hybrid chiller, VDR, which is a reversible heat pump, and boost heat unit, which is a gas-fired CO2 heat pump, which are assisted with solar technologies. And these are different ones. We have a vacuum solar thermal panels from TVSP Solar. Then we have photovoltaic panels and solar thermal panels from VDR, and a hybrid solar panel from DualSun. Thanks also to storage, the solar technologies can be, the exploitation can be maximized, and it supplies different needs. For instance, space cooling, space heating, pool heating, and domestic hot water. Depending on the combination and depending on the technology package, we will have different coverage of needs and different combination of the technologies. For example, we have technology package 1, which is an innovative gas-fired heat pump supported with the high vacuum solar panels. In winter, we have the TVP solar panels covering the space heating and domestic hot water needs. And in non-solar periods, boost heat will assist the demand. This technology package is applied in Berlin and also in Verbiers. Then we have technology package 2 with the hybrid solar panels, which assist the evaporator of the boost heat pump to supply space heating, domestic hot water needs, and in one demo case, the heating of a swimming pool. Also, the hybrid panels will also produce electricity, so electricity needs would be covered as well, and is applied in Nuremberg, Riga, and Verbiers demo sites. Then we have technology package 3 with TVP solar as supplying the needs mostly in winter for space heating, and then in summer it drives the adsorption unit to provide the space cooling needs. This technology package is applied in a tertiary building in Sant Cugat in Spain. Then we have technology package 4, which is similar to technology package 2, but with a reversible heat pump. In this case, the hybrid panels will drive the evaporator of the reversible heat pump to provide the space heating and domestic hot water needs. And when possible, also the solar panels will provide some of the needs. Also, there is a backup heat pump to supply space cooling in summer, and when the other heat pump is not possible to be used. And then the electricity from the hybrid panels will drive the compressors of the heat pumps and also cover the electricity needs of the demo sites. And it's applied in Madrid and Piera. Finally, we have technology package 5, which is is not applied in any of the demos, but it's only studied in simulations, but it combines more technologies. It has the TVP solar panels to drive the heating needs mostly, and domestic hot water needs in some cases. And then in summer, it will drive the Fahrenheit unit to supply the space cooling needs. When non-solar periods, when there are no solar radiation, then we will have the boost heat pump to supply the needs as backup. These technology packages has been studied in the project with transit simulations, and we have estimated that the technology packages will allow to save 33 to 7% greenhouse gases emissions, as well as 30 to 85% of operation costs in the different demo sites. You have the presentation, so you will have more details about the different performance of the technology packages and where are these applied. Finally, as a summary, I would like to remark that the Sun Horizon project has combines in an innovative way different heat pump solutions that mostly are driven with natural refrigerants and that are also assisted with solar technologies. And it allows to supply the demand with lower emissions, energy bills, and lower fossil fuel dependency. So finally, it could help to decarbonize the heating and cooling sector if the technology packages are replicated in more sites. That is all from my side. Don't forget to follow us on Facebook, Twitter, or check out our website. And that's it all from my side.
Thank you very much, Andrea, for your presentation. Now, even if it's not in agenda, I would like to present you our project coordinator, Federica Foligno from RINA, who would like to give a few words. So Federica, the floor is yours.
Thank you very much, Serena, and thank you all for attending this great workshop, greatly organized. And Andrea, thank you for having already said it all for this project. It's you're right. It's a very comprehensive project. We have several demo sites on board with 9 buildings in different European climates and many technological packages. So it's now we are in a critical moment for the project. Is in a very challenging moment because we will arrive in month 36, which is September, to have to complete the installation in all our demo sites, or at least to be able to demonstrate, to start the demonstration in most of them. And therefore, you can imagine that our consortium now is working full speed to try to put this very complex implementation on place. So we are very astonished and very happy of the collaboration that has been established with all the partners in the consortium. I think the project is going on greatly. And from my side and from Laura Giovannelli, which is with me, the coordinator of the project, we are very happy and looking forward to hear the next presentations about the technology packages and the heat pumps in particular. Thank you very much.
Thank you very much, Federica. So we can now proceed with the second presentation, which is a policy overview of the current heating and cooling policy. So I would like to introduce Josephine. Josephine, the floor is yours.
Yes, I am sharing my screen. Do you see my screen?
Yes, if you can put in presentation mode, yeah, perfect.
Yes, perfect. Okay. Good morning, everyone. I'm Josephine van Beeselaere, and I'm Head of EU Affairs at EHPA, the European Heat Pump Association. And I will give you an overview of the main heating and cooling policies at EU level and also our priorities as EHPA. So first of all, EHPA, it's the European Heat Pump Association. And yeah, we are one of the partners in the Sun Horizon project. We cover around 143 members, and it's very important to note that we are very horizontally organized. So we do not only have component manufacturers or heat pump manufacturers among our members, but also national associations, consultants, and research and test institutes, universities, and so on. So also this research and the scientific aspect is very important for our association. And our vision is that in a fully decarbonized Europe, heat pump technologies are the #1 heating and cooling solution. And that's also what drives our advocacy work. Okay, I'm trying to go to the next slide. Yes. First of all, I would like to stress that we have actually already quite a strong market foundation for heat pumps. So if we look at the statistics, we see that over the past 8 years, the heat pump market has grown. And over the past 5 years, the annual sales have actually nearly doubled. And by now we have about 14.8 million heat pumps installed. And if you look at the building stock in the EU, which is 115 to 120 million buildings, we actually exceeded a 10% market share. And that's very important. So in order to continue a growth of heat pump, you need to have a good market basis. And we have reached a good market basis of 10%. So now it will be easier to grow, let's say. And we also expect a growth in the next years due to policy aspects. So as I will show now, we already have quite a solid recognition in legislation and also ambitious targets. So this slide gives an overview of the legislation currently in place that is covering heat pumps. I will not go into all these details, but to summarize it, you see here in green all the legislation related to the Clean Energy for All Europeans package. And this covers legislation on energy efficiency, on renewables, on building codes, and so on. So if these are all implemented at national level, these are all very good for the heat pump development. So that's why you see all these pluses on the side. Then we also have more technical, more complex legislation. So that's on the one hand, the F-gas regulation, and on the other hand, the F-gas, the eco-design regulation. And they all guide the sector towards, on the one hand, fewer greenhouse gas emissions in F-gases, and on the other hand, increased efficiency in the appliances. So these are functioning well. But despite this very good recognition in legislation, we still see that growth is not enough, because if we look at this statistic, so this is a statistic of the renewable energy share in heating and cooling from Eurostat, and the green with the white circles, so the green dots with the white circles around is actually renewables in heating and cooling in specific. And there you see between the first renewable energy directive that was implemented in 2008 and the second one from 2018, there has only been an increase of 4.2 percentage points of renewables in heating and cooling, which is very slow, especially when you know that in the second one, there is a target to have an annual increase of 1.3 percentage points. And then you know that, if you look at the numbers, it has only been the last years less than 1 percentage point per year. So we really need to increase our efforts to only reach the current targets that are in place. And that's also a message that is in general very well, received, or also very well known at EU level. So now there's this EU Green Deal package and a climate law of Commissioner President von der Leyen, who wants to achieve minus 55 CO2 greenhouse gas emission target by 2030. So an increase of this target. And this will also have an effect on the renewables and the energy efficiency targets, which will have to increase from around 32% now to around 40%. So the ambitions are really increasing. And that we will also see in the legislation that is coming up. So this purple boxes, there is new legislation that is coming up in the framework of the European Green Deal and the climate law. And there's not only additional legislation, but also many of these green legislations that I mentioned before will be revised to become more ambitious and to achieve this higher target by 2030. Also, in the framework of this EU Green Deal, there have been some important communications and strategies published. The first one is the EU Energy System Integration Strategy. And in this strategy actually looks at how to better integrate the energy system, so production, consumption, infrastructure, and so on, and to have less separated silos, but really a better integration. And heat pumps are recognized there as a key aspect of energy system integration. And there's also clear targets that are put. So you see this 65 and this 40%. So in this strategy, there's a target of that the EU wants to reach a 65 electrification of heating in the commercial sector by 2030 and a 40% electrification of heating in the residential sector by 2030. And if we then look at the current building stock, this would mean that we would have to achieve around 42 to 52 million heat pumps by 2030, which is actually a quadrupling of today's heat pump stock. So this is very important for our sector, but our industry already confirmed that they can do it, they can increase their production. Another communication that is very important is the renovation wave. And this communication also mentions the decarbonization of heating and cooling as a very important aspect. And the main target is actually to renovate the 35 million least performing buildings by 2030. And also this is very important for heat pumps because these 35 million least performing buildings, when renovated, are all perfect heat pump candidates. So that's very good as well. So if we look again at the overview, then we see first this strategy that puts this very concrete targets. Then we see the renovation wave that also has this renovation target. And then we have the climate law and this 55% CO2 emission reduction. There we will have the Fit for 55 package, which is actually this revision of all these legislations that I mentioned before. So EED is the Energy Efficiency Directive, RED, Renewable Energy Directive, and EPBD, Energy Performance of Buildings Directive. So these will all be reviewed to achieve these targets. And in all three of these things, heat pump technologies are essential to achieve the targets. So as I said, we have a strong market share. We have already a strong recognition in legislation and ambitious targets. But now what is also needed is to really activate end user demand, because it's not enough to just say, okay, we can increase the production. No, we also need to have the demand to match. And a crucial aspect there is that the best technology also has to be the most affordable. One of the aspects there is that we very often see in many member states that electricity is still taxed much higher than fossil fuels. And there we really need to have a level playing field so that the best technology, when we look at energy efficiency and renewables, also becomes the most affordable, and it guides end users automatically to these solutions. So this is something to address urgently. So the way forward. So as said, the industry is ready to increase the production. The increase in demand is needed. This should be tackled by looking at electricity taxation, also looking at the CO2 price signal, and also eliminating the fossil fuel subsidies that still exist today. And then we have a great opportunity for a further large-scale growth of heat pumps. So as said before, this is actually a summary. So the industry can deliver, but we need the right framework conditions that trigger this end user demand. So as mentioned, we will have this Fit for 55 package. So this revision of this group of legislations that the Commission will propose in July. And we, as EHPA, are focusing on a few key points for this package in our advocacy work. First of all, it is that we have to look at heating and cooling policies more aligned, because now this is scattered in different legislation. So as I mentioned, you have the Energy Efficiency Directive, you have the Renewables Directive, but we should really look at these, more in synergy and stimulate more these technologies that both are positive for our energy efficiency targets and our renewables targets, such as heat pumps. A second aspect is that we really should unlock the full potential of heat pump technologies, because very often now there's only, these legislations only look at residential heat pumps or electric heat pumps, but we should really look at the whole package. Also industrial heat pumps, hybrid heat pumps, and so on should be covered. A third aspect is that we have to guide our citizens to efficient and renewable heating and cooling solutions for their buildings. So this is more on the building codes, building regulations, and there an important part is one-stop shops for heating and cooling renovations, so that citizens are really guided from the start to the end of the process, helped in their administrative work, that really the right choices are made for them, and they are really guided into detail into the whole process, and this will really facilitate renovations. And then the last aspect is what I also mentioned before, is that the pricing needs to be reviewed. So the end users are guided automatically towards the best solutions. So therefore taxation needs to be rebalanced. Also effects of fossil energy use should be internalized and so on. So this is what we are really working on at this moment. And I would say if you are active in the heat pump value chain and you are interested in this, you would like to contribute or know more about this, do not hesitate to contact EHPA or to become a member. So thank you very much.
Thank you very much, Josephine, for your presentation. We can now start the session dedicated to the heat pump deployed in the Saint-Horizon project. So I would like to invite Sebastian to share his screen, and Sebastian will present the solar hybrid heat pump provided by BDR Thermea in the Saint-Horizon project.
So I guess you can see my screen now.
Yes, if you can put in presentation mode, it would be great.
Here we
Amazing.
go.
Yeah.
So hello everybody, thanks to inviting me to share also the work we do all together within the Saint-Horizon project. I'm Sébastien Vacher, I'm the head of R&D and innovation for heat pump within the BDR Thermea group. And today I will present the job we did on some demo site and the reason why we have decided to invest time in this project. But before going through this presentation, I just want to have a brief company overview to really understand who we are and what is our mission within BDR Thermea. And so you will understand the reason why we have decided to integrate the Saint-Horizon project, because our mission is we want to bring a zero carbon future closer through smart thermal comfort solutions. So you can easily understand that it's one of our target to decrease drastically the primary consumption for our heating solutions. Basically, BDR Thermea is a worldwide company, around 2 billion turnover. We are active in more than 100 countries, and we have more than 6,000 people around the world. And we have invested hugely in terms of R&D, because we have 12 R&D centers worldwide. And if you look at heat pump, we are based in France, close to Strasbourg. And we have more than 100 R&D engineers working for the development of the heat pump for European countries. If you look a bit of our brand heritage and our presence around Europe, you see that we have quite an old story, because we started in 1684 with De Dietrich, which is one of the premium brands in France. We also have Baxi, which is one of the leader company in UK, in Italy, and also in Spain. We also have the brand Bröcher, which is really well known and one of the leader on the heating industry in Germany. And we also have our brand Remea, which is also one of the leader in the Netherlands. So basically you see that we have quite a long history. And basically the reason why we have this long history is that we have been able to change and to evolve according to the evolution of the need of our customer. And basically, we are really excited about our future, and the future goes through also the Sun Horizon project. So now, if we look at the solar hybrid heat pump, and what is a solar hybrid heat pump? So basically, that's a combination of an electrical heat pump and multiple solar sources. As you know, as you may know, we have quite a large range of electrical heat pump within the BER group company. And we have air source and ground source heat pump. We can deliver heating, cooling, and domestic hot water for residential and collective application. And basically, we wanted to combine our electrical heat pumps with multiple solar sources to check what would be the improvement of the seasonal efficiency. So on the different demo sites that I will describe later on, you will see that we have combined our heat pump with PV panels, so for the production of electricity used by our heat pump, solar collectors also to provide thermal energy for the use of domestic hot water mainly. And we also have hybrid collectors and PVT for the production of the thermal energy, but also electricity. So the reason why we have decided to look at this combination, this hybrid solar heat pump, is basically simple mathematics. Basically, we are trying every day to improve the efficiency of the heat pump on its own. But basically, we also believe that combination of different sources, but also, and specifically, the solar sources could help to have an efficiency booster. So if you look at this graph, so at the bottom of the scales, you will see the proportion of the PV electricity. And on the left side, that's the global efficiency of the heat pump. So if you look at the basis, a normal heat pump, which is with a COP of 4.2 for the sake of the example, and you just implement or produce and consume by the heat pump 50% of electricity, by simple mathematics, you can understand that we will increase by 2 the global efficiency of the heat pump. And for sure, if you continue to increase the production of electricity, if you 2/3 of electricity, then you increase by 3 the efficiency of the heat pump. So that's a first reason that we have decided to invest in this project, to check and to learn how to improve the efficiency of our heat pump through a combined solution of systems. So that's if you look at the PV panel. If you look at the PVT, so the hybrid collector, which can provide photovoltaic, but also thermal energy. So here, for the example, we took ground source heat pump. So basically, if you want to improve the efficiency of the system, you can combine the improvement, the use of the electricity from the heat pump, but also to increase the water source temperature with the solar collector. So basically, on the example, you see the impact if we just increase the water source. From 0 degree to 10 degree, you increase from 4.4 the efficiency to 5.5. But if you combine the effect of the increase of the water source plus the consumption of the production of electricity using this hybrid collector, then you can see that we increase by 2.5 times the efficiency of our water sources. So that's basically the first assumption that we took to start to work on this project. And basically to go a bit deeper in this analysis and to check if the modeling we did on this, on the saving on the efficiency could be checked also on the demo site. We invested in 2 different demo sites, as it has been previously explained. So one demo site, Pierre, which is close to Barcelona for the non-Spanish people. So we have installed into a residential house air source heat pump of 6 kilowatt combined with 5 PV panels and 2 thermal panels. So our modeling shows that we can expect a saving of the primary energy consumption by 55%. The second demo site is based in Madrid, which is more for a collective application, because here we have 2 heat pumps, one air source heat pump of 27 kilowatt combined with a ground source heat pump of 9 kilowatt and 50 square meter of PVT, which can provide then thermal and electricity. And here on this demo site, we can expect a saving on the primary energy of 77%. So which is a huge step if we want to improve the global efficiency of the heat pump. So basically, we did a lot of modelings on the buildings to define what is the best and the optimum size of the PV and the PVT compared to the need, and because we deliver not only heating, but also cooling and domestic hot water. And basically, the main reason that we have decided to invest on this demo site is we want to check the simulation done and with the real life figures. First, to improve the management on our heat pump to make it more efficient when we combine all the system together, but also to prove that the combination of this kind of system could also help us in our mission to reduce our carbon footprint, and also linked to the discussion presented with the EHPA presentation, that the cost of the energy and electricity and the taxes linked to the electricity is key if we want also to reduce our carbon footprint. So that's basically the presentation and the project we are investigated in the Sun Horizon project. So if you have questions, you can send a message in the Q&A chat and we will respond later on. And else you also have my mail address and you can contact me if you want. Thank you for your time.
Thank you very much, Sébastien. We can now proceed with Norbert, who will present the natural gas-driven heat pump from Boostit. Norbert, the floor is yours.
Yes, thank you very much. I just have to choose the right screen here. That one, number 2. Can't see it. Okay. Good morning, ladies and gentlemen. Now we are going into a different world. We are in the gas world now. So let's talk about gas-driven heat pumps, and not by conventional activation, but by thermal compression, which is a new way of driving a gas heat pump. I explain you what's the advantage and why it makes sense to talk about. We all know why we are here. We have a common global problem. We want to address and solve that problem. And we are facing a huge number of existing buildings. Buildings which have been built 100 years ago, before the war, after the war, and most of them still show conventional heating systems. So we are confronted with a situation in which people are used to a specific way of heating, to existing infrastructure, old tubing, old radiators, low insulation standards. You all know that. And we, a French team, which started nearly 10 years ago in developing a new technology, started from that point and considering what might be a good way to address that huge global customer problem, at least in Central Europe. And for us and our partners, we decided to focus on the gas vector. Whatever gas it will be in the future, it will get greener for sure, but it's compared to an electricity line, something which comes with a much higher power always available. It comes as a storage in its own, and it comes with a huge existing infrastructure. So based on these fundamental ideas, we started to do fundamental research. And today we have a first product in the market in small numbers. And the Sun Horizon project is our first big project in which we show in these given sites all over Europe what the technology is able to supply. The company started to work in 2011, so we have a 10 years history. Directly responding to one of the questions in the Q&A, from the pure beginning, we focused on CO2 as a refrigerant. We're convinced that CO2 has a big future. Our small size, small power solution, 20 kilowatts of power as a design scope, shows that it is feasible to run such a machine on CO2. I will explain you later what is the price you pay for. By today, we have around about 80 installations, most of them in France, some in Germany, and some in Switzerland. We sold around about 400 units in 3 months. Then COVID came with lots of issues, you all know them. We are in the meantime 50 colleagues, experts in the field left. Our main site is Lyon in France. And our aim is to come close to a promise of cutting into the final energy demand by the mechanism of a heat pump, which is run by gas, not by electricity. So what's the technology about? It's a cycle, a closed loop system using only CO2, no other phase. It's in 2 phases within the cycle. Sure, it's gaseous and liquid, but there is no absorbent or no ceramics, no rare metal or anything else which you might use from other heat source systems. So it's pure mechanical engineering, a lot of steel, high pressure, high temperature. We're operating the upper point in the circle at 100 bars and 90 degrees, and we go down to 30 bars around about 30 degrees. It shows similarities to Stirling, but it's just half of a Stirling. We are using a displacement piston at very low frequencies. The piston is necessary to modulate the thermal cycle. So we have a moving part. Yes, this is an issue. It took us a lot of time to get it well done. And this displacement piston is controlled by a step motor, which is inside the high pressure area. So what is the reason we do that? Yes, CO2 has strong advantages regarding the climate impact. It's available all over the world. It's not depending on an industry or on specific supplier restrictions. The concept of working with CO2 and hence having a high pressure vessel system, which is designed in an intelligent way, not to make it necessary to have annual inspections, makes it easy to handle. The refrigerant circuit is limited to the compressor itself. So it's a split system, which makes it easy to install. And with the approach of having such submodules, we are prepared to ramp up quite fast. By today, we are still manufacturing in small numbers. Let's say the key differentiator regarding absorption heat pumps, which are sometimes also mostly thermally driven, then electric heat pumps in our system, we are just using external temperature without a solvent, so no physical reaction inside, and we're not depending on the available electricity power on the grid. On the other hand, we cannot feed in PV electricity. This is an issue. We have a small electric consumption, which is in the range of that of a conventional condensing boiler. Our product is not yet available in large volumes. We are manufacturing it on our assembly line. We have, as you've seen, around about 80 installations so far. We are coming up with a second generation now. The environmental impact in our case is mainly the material, the pure steel and copper inside. The 20 kilowatts combined heating system, which comes also with a 65-liter domestic hot water storage in its empty situation, weighs around about 460 kilograms. It's 2 meters high, so it's also a challenge to optimize the logistics. We have a high thermal inertia, so the system modulates down to 4 kilowatts, and due to the thermal inertia, it's also relatively comfortable to work in the start-stop mode. Also, we prefer to have it continuously running. The product concept is quite easy. It's the combination of the thermally driven gas heat pump with a conventional gas condensing boiler, both together supplied as a unit, with the intention to ease the sales process. This has shown that it works. We just come up with the promise, we are replacing your conventional oil or gas boiler within 1 to 2 days of standard work for a normally qualified installer. It connects to the existing heating distribution system. It connects to the hot water system. It can be operated with a domestic hot water external tank. We don't recommend it. We prefer not to store additional thermal energy, as we think gas is a better energy storage. Burn it whenever you need it, but not upfront. And we need to connect to the chimney system, at least in the Germanic countries. In Southern Europe, sometimes it's easier. And we need to connect to the condensed water garbage system. Our efficiency values, which we have proven and shown in the field so far, yes, they depend on the heating circuit temperature. The characteristics of the machine is that the higher the split in the heating circuit in temperature, and sure, the lower the temperature, the higher the overall efficiency. But as we are driving the compression by burning gas with an open flame, we already have at hand the driving energy as a heat source. So half of the necessary heat is already available at hand, and the second half is brought in by the heat pump mechanism. So we are already close to the promised cutting in half of the energy bill for air heat pumps. When we are talking about water heat pumps, we are close to a seasonal gas utilization efficiency of 2.3, which is in average good conditions. There's just a view in our assembly line site. It's a former Bosch diesel engine production site in Lyon. It's the southern part of Lyon, where we have highly automated the assembly process with a huge investment in quality control. By today, we are continuing to install. We restarted. We have not yet fully left the Corona issues. We have still limitations due to missing parts from suppliers all over the world. We have signed some collaboration agreements, and we are now close doing the first installations within the Sun Horizon project. We will start with one in Berlin, one in Nuremberg in Germany. These are old style houses where the principal idea is not to touch to the house, just change the heating source, bring in additional renewable energy by solar thermal or PVT collectors, combine them with advanced level split storage systems, and such try to bring down the overall thermal consumption of such a, in one case, 2-family home, in the other case, a 4-family home, by 60%. Thank you very much for your attendance. We're welcome to answer your questions in the Q&A session later on. You're welcome to visit our website, and you will find information in the standard languages also from our French side onwards.
Thank you, Norbert, for your presentation. We can now proceed with Bashir from Fahrenheit, who will introduce us the hybrid absorption compression chiller deployed in Sun Horizon. Bashir, the floor is yours.
Thank you, Serena, and thank you for organizing the workshop. Do you see my screen?
Not yet. It says you're not sharing. Okay, now, yeah, now we can see it.
Hello, everyone. My name is Bashir Qanawati, and today I will be speaking about the hybrid adsorption compression chiller. First, let me start by saying a few words about my company, Fahrenheit. We are a manufacturer of adsorption chillers, which are chillers that are driven by heat instead of electricity. The company was founded at 2002 at the Fraunhofer Institute for Solar Energy. And today we have more than 700 installations worldwide. We have more than 30 patents granted. We have our headquarters in Munich and our R&D and production in Halle an der Saale. Today I will be speaking about our hybrid solution that combines the adsorption technology with the conventional compression. So let's first start by talking about the adsorption part of the hybrid solution. As I said, it is driven by heat instead of electricity, which leads us to savings up to 80% or more in electricity in comparison to conventional state-of-the-art compression cooling. We use water as a refrigerant, so there aren't any synthetic refrigerant in the machines, and there are no moving parts inside the modules of the machine, which simplifies the process and helps establishing a sustainable infrastructure. Now, how do we generate cooling with adsorption? We use the physical property of the sorbent material, which is in our case silica gel or zeolite. It has the ability to attract and absorb the water vapor. You see here a picture of a demonstrator. We have on the right side, we have two glass containers. On the right side, we have water, and on the left side, we have the sorbent material. In this case, it is zeolite. Both are under vacuum. In the demonstrator, when we open the loop between the two glass containers, the zeolite will attract the water vapor and absorb it. And under vacuum, water will evaporate under low temperatures, creating the cooling effect and chilling effect. Let me play the video. We open the loop between them, and water will start to evaporate, and the water will freeze within seconds. Now, we reach a point where the zeolite cannot absorb anymore. It is full, and this is why we need the heat to dry the zeolite and restart the process so that we can cool again. Now, in our chillers, we have heat exchangers that are coated with this material, with the sorbent material. This is, in this case, the silica gel on the left side heat exchanger. Our machines consist of modules. Each module contains two heat exchangers, one that is coated with the sorbent material and the other that functions as an evaporator or a condenser. The same with the demonstrator that I showed. Water will evaporate and it's attracted to the adsorber, creating the chilling effect. And when we reach the point where we cannot absorb anymore, we cannot generate cooling anymore, this is when we need the heat. And in this case, we have another identical module that will then operate in the same phase to generate cooling so that we can ensure continuous cooling. So our machines consist of identical modules that switch in operation between adsorption and desorption in order to generate cooling continuously. Inside those modules, there aren't any moving parts, which as I said, simplifies a lot the maintenance of the machine. It has very low maintenance requirement. We use only water as a refrigerant, and there aren't any toxic or climate damaging substances. Now, a typical adsorption system consists, other than the chiller, of three water circuits. The first one is the drive circuit, the heat. which is in form of hot water at a temperature from 60 or even lower up to 95 degrees. In Sun Horizon, we are using solar heat, but we can use also any other type of waste heat. The chilled water circuit, which we use to deliver the cooling for different applications, whether it is for air conditioning, process cooling, or others. And then the recooling circuit, which we use for heat rejection. We can use either a dry recooler or cooling tower or any heat sink. Now, the capacity of absorption depends on all three temperatures in the circuits. The higher the hot water temperature, the higher the capacity. The same with the chilled water circuit. The higher the chilled water circuit, the higher the capacity. But on the other hand, for the recooling circuit, the higher the temperature, the lower the capacity. So when we use dry recoolers, the capacity of the absorption chiller will depend on the outside temperature. Now, this is how a typical cooling load for air conditioning looks like. We have on the x-axis the outside temperature, and we have the cooling load on the y-axis. And of course, the cooling load will increase as the outside temperature increases. We have the yellow line here that represents the occurrence. How many hours does this outside temperature occur per year? And of course, at the higher temperatures occur only for a few hours per year, which is why we recommend that absorption is designed for base load coverage. So we recommend covering the hours where we have lots of cooling demand with absorption, and then we will have some peak load that requires covering only for a few hours, and this is where we need a backup system. Now, this helps with the reliability of the overall system and also helps with the limitation of the heat, because it can be that the available heat is not enough to cover the whole cooling load. So this backup system is recommended for absorption system, and this is why we introduced our hybrid solution, the hybrid chiller. The hybrid chiller contains the absorption part, the absorption chiller, and also an integrated compression chiller that operates whenever required. So whenever we reach the peak load, or whenever there are fluctuations in the heat because of the lack of radiation or any other reasons, the compression part will automatically jump in and cover the missing cooling demand. As I said, the hybrid solution that contains the compression part, for example, here on this side, and the absorption part on the left side, will help cover the peak load and increase the overall efficiency of the system. It will reduce the payback period because we do not have to invest in additional absorption and solar energy. It also gives us another range of applications where we can utilize absorption cooling. And it also can be used as a backup when we have fluctuations in the available heat. We also offer the hybrid chiller with propane as a refrigerant to also comply with the regulations. Propane has a global warming potential of only 3. There are 3 operation modes for the hybrid chiller. Either the absorption is covering the whole load. This occurs at the most within the base load coverage mode, or the compression is functioning alone. This occurs mostly at night, for example, in solar cooling applications, or both systems or both units can operate at the same time in parallel to cover the whole cooling load at the highest outside temperature. Within the scope of Sun Horizon, we are installing a hybrid chiller in the demo site in Satkugat. It has a capacity of up to 100 kilowatts. From that, the absorption part covers up to 40 kilowatt, and the compression part covers up to 60 kilowatt. We are using a propane as a refrigerant in the compression part, and as I said, of course, water in the absorption part. And yeah, we are using solar energy, of course, as a drive energy for this demo site. Thank you very much for your attention.
Thank you very much, Bashir, for your interesting presentation. We can now proceed with the last presentation for today, provided by Joseph from Veolia, who will give us some insights about the Sun Horizon business models and what are the ESCO perspective.
Yes, thank you, Serena. Good morning, everyone. Can you see my screen?
Yes, we can. Can you put in presentation mode?
Yes, perfect. Can you see it?
Not yet. I see the normal view. I think the presentation mode is not set yet.
Is it set now? Because I can see it here on my screen.
Not yet. I see it normally with these more slides on the left. Okay. Now it was working. Yeah. So maybe there is a short delay.
Okay. Okay. Well, I'll start anyways because it's in case you cannot see it or there's an issue, please, Serena, come back to me and I will try to fix it up. Okay, perfect. Well, thank you very much, our colleagues, with their interesting presentations. My name is Josep Mitats. I'm a project engineer at Veolia Serveis Catalunya, which is the Catalan branch of Veolia's worldwide company, which, as you may know, it's leader on water treatment, waste treatment, and energy services. And today I will speak about the Sun Horizon business models perspective and our ESCO perspective on the project. Well, first of all, what we'd like to share with you all is the primary concept of what is a business model, because we kind of mix it up different concepts between us all, and there's different approaches on those terms. And I wanted to share a definition of Osterwalder, Pigneur, and Tucci. As you can see here, a business model is a conceptual tool containing a set of objects, concepts, and their relationships with the objective to express the business logic of a specific firm.
Joseph,
therefore, we must. Yes.
Sorry to interrupt, but we still see the first slide and not in presentation mode. So if you can try maybe to type F5. Yeah, because also the slides were not moving.
Not moving.
So now we still see the first slide.
Yeah, I don't know why, because yes.
Otherwise, I can share it.
Yes, please, if you can share your screen, because in that case, I think it would be better. Because I think that my computer is a little bit slow on that side.
No
so maybe you can share it, Serena, and I will say to you whenever we can change the slide. Okay.
Yes. Let me.
Okay. Thanks. Perfect. Yes, this is the okay. Thank you, and let's move on. As I was saying, there are different tools or methodologies to assess the creation of a business model. In that case, we have the Canvas methodology, which, as it is stated, is a tool for describing, analyzing, and designing business models through 4 basic pillars. In that case, this is the infrastructure management, product innovation, customer relationship, and the financial aspects, which are split into more specific essential business building blocks. We also have the SWOT methodology, which is the acronym to Strengths, Weaknesses, Opportunities, and Threats, which is also a tool to evaluate the internal strengths and weaknesses, and also, as the name says, the external opportunities and threats in an organization's environment. And those are very useful tools to assess the primary concepts of a business model and to assess which is the product innovation and the value proposition that we want to assess. Next slide, please. Thank you. And now focusing on what we want to discuss today is what is exactly an energy service and what is an ESCO. Following the definitions of the different European directives, an energy service is the physical benefit, utility, or good derived from a combination for energy with energy efficient technology or with action. In that case, which may include the operation, maintenance, and control necessary to deliver this service, which is served on the basis of a contract in which conditions that are to be established within the client and the ESCO. And again, an energy service company is a natural or legal person, usually in the form of obviously a firm and company, to have a much powerful management capability, who delivers, serves these energy services or other energy efficiency improvement measures in a final customer's facility or premises. And obviously, the ESCO bases his remuneration on those energy services that, as you can see here from the picture, vary on different terms, such as energy supply contracting, energy performance contracting, energy management of the systems, energy consultancy works, project design and installation process, and so on. Next slide, please. Thank you. So in what terms does the ESCO offer those energy services? We have different provisions. We have adapted a little bit our business model concept to the Sun Horizon project. And we have envisaged 4 main provisions that are to be conducted depending on the final technology installations on the different heat pump technologies. In that case, we have provision 1, which is the energy management, which performs all energy management tasks, in that case referred to the supplying warranties in terms of quality, quantity, safety, and lowering purchase costs via these contractual arrangements that we will see a little bit later on. Provision P2, which is maintenance, performs the different types of maintenance, legislative, predictive, normative, corrective maintenance tasks. Provision P3, which is conducting the full warranty repair in case any of the equipment that is being deployed needs to be repaired or changed. And this service is meant to provide all these services so that the ESCO assumes all technical and substitutional risks of the equipment devices installed. And provision P4, in case of big ESCOs or dealing with previously arranged loans with the banks and so on, we can have these improvement works and installation renewal, which in that case, the ESCO takes or provides the regular innovation improvement analysis so that new equipment can be deployed on the client's facilities, considering different financing possibilities. Next slide, please. So when referring to the energy management and services provision, which is the P1, we have different types of contracts. In that case, we have the energy supply contract, which again here stated the definition of it, which is a contractual arrangement where the focus is the reduction of supply costs rather than the demand side efficiency gains. In that case, we usually, or the subject of this contract are usually the supply of energy in terms of heat, but it can also be in forms of compressed air, electricity, and so on. That depends on the client's needs. And as we were saying, the focus here is the reduction of the current costs. Next slide, please. Thank you. Those are kind of the kind of contracts that we're dealing more here at, for example, Veolia's Catalan business unit. In that case, this is the energy performance contracts, which is contractual arrangements where the investments can be referred to work, supplies, or even a service, are paid in relation to a contractually agreed level of energy efficiency improvement that it's meant to be established in the contract, and other, for example, energy performance criterion such as energy or economic savings, and including different ways to design, measure, and control them. In that case, we have different types of contracts. The guaranteed saves contracts is those ones where the ESCO guarantees at least the minimum savings that will be obtained while implementing those energy conservation measures. And the shared savings contracts, where the savings obtained with the implementations of these energy conservation measures are shared between the client and the ESCO. Here there are the different possibilities, considering that the current cost is the one that is being analyzed by the ESCO, and the estimated cost via the different tools and simulation units and tools that we have here in our offices. And depending on whether the estimated cost is bigger or lower than the estimated one, we can incur in some extra cost that must be fulfilled by the ESCO, or again, if our estimations are not optimistic as they finally are, then we can share the savings between the ESCO and the client. Next slide, please. Thank you. And last but not least, another way of contracting is the forfeit one, which is kind of more risky for the ESCOs, because that means that it is a contractual arrangement where there is an agreed amount of energy. In that case, we call it guaranteed consumption, and the price per year is fixed with some technical parameters. In that case, agreed ones such as degree days, occupancy profile, performance regarding the equipment involved, and so on. And this price is reviewed annually according to the variation of these parameters, which we call the revised guaranteed consumption, with a formula that is also established at the beginning of the contract and established there. And again, there are different scenarios. In the case the real consumption is bigger than the revised guaranteed consumption, the ESCO takes care of the extra cost. If the real consumption is lower than the revised guaranteed consumptions, then the savings are shared between the client and the ESCO in a stated percentage, again stated in the contract. And if the revised guaranteed consumption is lower than the guaranteed consumption, the ESCO has to return the difference to the client. Next slide, please. Well, yeah, as stated before, we have different ways of providing these service contracts or arrangements, and we might include different services. In the case, for example, of Sonorizon, we might see the scope of the installation works, and always depending on the client's needs and perspective, we can offer a combination of these 4 provisions. Only one of them, only 2, 3, 4 of them. That depends on the client's needs and our expectancies, and obviously the relationship between us, the ESCO, and the client is essential to gather all the needed information and to see what is actually needed from the client. Next slide, please. As we were saying before, how can we finance all these works and services that the ESCO has to provide? In the case of energy performance contracts in the guaranteed savings model, usually the client asks for a bank loan through a fixed payment, and then pays the ESCO implements the project and provides the savings guarantee, and the client pays based on these obtained savings. In the energy performance contract, in the shared savings one, the ESCO can also take care, or usually takes care of, the bank loans, or has its own financial strength to assume this cost. And in the super ESCO model, the ESCO can provide all the technical and financial possibilities so that it can be assumed all technical and both economic risk by the ESCO. Next slide, please. Well, as the ESCO business model benefits, you know that externalizing some energy services through an ESCO, those terms, the exploitation plan of a customer's energy infrastructure, can provide several benefits to the client. In that case, we list here the most important ones, which is obviously the energy saving and the cost savings. The GHG emissions reduction, usually CO2, but depending on the client, if it's industrial, obviously it can vary, and it can include some other gas reduction. The transparency, obviously, which is highly needed in terms of the client on energy and operational costs. The minimization of technical and operational risks, as the ESCO takes those risks and has experience on dealing with the project management and implementation and deployment tasks. The fulfillment of normative and legal aspects, in that case, compliance with all activities performed. The energy assets optimization, because obviously with a comprehensive maintenance plan, we can offer the expected guaranteed savings or expected shared savings, and the client has also his ways to keep a maintenance plan that fulfills all those objectives. The development of a corporate image, in that case, to show commitment with energy efficiency, and the enhancement and guarantee of installation financing options, because either the ESCO or the bank can negotiate terms and conditions of the financing of the improvement. In that case, for example, the P4 provision, and it can offer a lot of benefits, financial benefits in this regard. Next slide, please. Yes, in that case, well, I just want to thank you all for your very good presentations. From our side, we are here to answer any questions that you have, and don't hesitate and contact via email if you feel like. Thank you very much.
Thank you very much, Joseph, also for your presentation. Now I would like to officially start the panel discussion. So I'll ask the entire panel to please turn on your cameras. Thank you. So we received quite a lot of questions. So let me check both the chat and the Q&A. So just a second. Okay, I would like to start with one question that is addressed to the heat pump providers. So the question was, what do you think of CO2 as a refrigerant, and what is your opinion on that? We can start. I see that Sebastian is already unmuted. If you want to answer.
Let's take the floor. Yes, as explained, Boosted is convinced, and we get a very positive feedback from our market partners and also from the end users that CO2 is heavily appreciated. It needs some explanation because people mix it up with the exhaust and with the emission issues, which they read in the newspapers. But once understood that CO2 is something confined in here, our 20 kilowatt machine comes with 4.2 kilograms of CO2. It eases their life by not needing any further inspection nor any advanced sensing or alarm systems. So in most cases, there is freedom to operate and to install wherever you want. So we have even customers who installed the heating system in their sleeping room without any concern. So CO2 is still quite unknown, but once you get familiar with it, and when it's designed as a split system, it means that the installer even does not need a cooling certification, a cooling technology certification. Every heat plumber is allowed to install our system without any additional training. This is really, let's say, a quite positive way to address the market. But for a manufacturer, it's difficult because the high pressure requirements took some time to get, let's say, well solved.
Okay, will Bashir or Sebastian would like to add something on this? No.
Yeah, maybe
Okay.
just one word on CO2 on electrical heat pump. I think it makes sense, and the reason that it has been, let's say, we have seen this technology is mainly driven by the Japanese and also highly subsidized because of the incentive on Japan. We believe CO2 makes sense, but we also believe that our new range of heat pump could provide more or less the same high level efficiency, also the same high level temperature, but with a more affordable product. So I think that's also one of the constraints of CO2 is extra cost linked to the technology itself.
Okay. Sebastian, since you are muted, I also have another question for you. This is from Thomas asking, so since in the near future we foresee that there will be an excess of renewable electricity in the grid, are you planning to use as an option battery instead of own PV installation?
Yeah, so basically within this Sun Horizon project, we started in 2017. So at that time, the market was not that dynamic in terms of battery and electricity battery or thermal battery. So within this Sun Horizon project, we will still be focused on the PV and on the PVT and the thermal panels. But for sure, as a global company, we are also investigate other solution, and this kind of battery could be also a solution. And also the market is really dynamic, and so we believe this could change the way we can provide the solution in the future.
Thank you. One question for Bashir we received. Which kind of solar collectors will you suggest to be coupled with your absorption chiller?
The range of hot water temperature is really wide. As I said, from around 50, 55 up to 95. So any kind of collectors that can reach that temperature can be used. Of course, the higher the better. So vacuum tubes collectors are really good. We are using in Sun Horizon the TVP collectors that has also a vacuum technology and can reach high temperatures. Is really optimal for the performance.
And one question that I think was also addressed to you, Bashir, but there is no name written, is about the technology package in which the Fahrenheit absorption chiller is coupled in a Sun Horizon. So if you are also, if we can tell more about this technology package.
The technology package we are using, as I said, it's a solar cooling project where we are using the collectors from TVP in winter for heating, and in summer to drive the absorption part of our hybrid chiller to generate cooling. The absorption part in the hybrid chiller will cover the base load, the base cooling load, and the compression parts will cover the peak demand in the summer. And also the existing system might operate whenever required if the Sun Horizon technology package is not sufficient for heating or cooling.
Thank you very much. Now, one question for Andrea. If you are aware and if you did a calculation about the total cost of ownership for each technology packages.
We calculated the levelized cost for heat and cooling, well, of energy, and it was estimated in between 7 to 12 cents of euros per kilowatt hours, but they were very much dependent on each case, and also on the cost of electricity, and therefore the country. And in the cases with the PVT panels, they also depend on how much energy is reimbursed. I mean, how much, how much energy is reimbursed when the production is injected into the grid. But yes, it was estimated between 7 to 12 cents. Hopefully, when the grid gets greener and cheaper, I think this cost will be, I mean, the levelized cost is expected to go down for sure.
Thank you for your question. Now we can go to Joseph. So I have a question for you. So a smart climate friendly quarter may include both replacement of grid electricity by local PV production, plus demand side flexibility to use more locally produced PV and less from the grid. How does this reflect into your model that separates supply from demand side flexibility?
Perfect. Yes, thank you, Thomas, for your question. Yes, in fact, the first step to our work is to have a first audit on which is the actual primary energy consumption and the final energy consumption from both generation and demand side. And then in terms of, well, in that case, that would be a P1 provision to analyze where the energy comes from and which is its final mix and usage. In that case, yes, we track the origin of this energy. Those cases, for example, we spare which is the electrical kilowatts and the thermal kilowatts, for example, in PSI, PSS, that depends on the contractual arrangements and the forms of defining which are the savings and which are the contractual needs of the client, and how does it has its own billing system and so on. And then obviously we try to adapt its installations and facilities in order to have a proper picture of their installations regarding the less use of grid energy as possible. For our case, we are trying to maximize the self-consumption use, and so that the installations can perform as much self-consumption quota as possible. So yes, in that case, our aim, and not to disturb the DSOs and TSOs, but is to depend as less as possible from energy from the grid, and obviously to track all these savings depending on their origin and their end use.
Thank you for your answer. I now see another question for the heat pump providers, but I think also Josephine maybe can provide her point of view. So do you think that is it possible to supply 5 million of heat pumps in the next few years, looking at European production possibilities? And if not, what are the obstacles that you see? Who would like to start? maybe Josephine, you could provide maybe more an overview on the policy side, I guess.
Yes, so, well, we definitely see it is possible to increase, the manufacturing of heat pumps. But as I mentioned, this large-scale deployment doesn't only depend on the possibility of the manufacturers to produce, but also the demand should increase. And there, the main obstacles are the costs, both capex and opex. So, and also the, how do you say, the how end users, the information of end users, the accessibility to the heat pumps, that they know that this exists. Also, to help them and guide them to implement this. So I think, the main things to tackle are, the capex, that subsidies should be foreseen, and that the member states should really help to switch to these energy efficient and renewable solutions. But also then to look at the OPEX, this energy taxation issue, as mentioned before, and then to these one-stop shops, I think, are really a key aspect to really guide end users towards heat pumps from, and to take away, how do you say, the administrative financial obstacles by guiding them in detail.
Thank you, Josephine. Norbert, Sebastiano, Bashir, would you like to add something?
From our perspective and with the experience, especially in the German market, we see the main barrier in the lack of qualified workforce for the installation work. So if you are ordering at whatever price a heating system in Germany today, you won't get a cheap one, the price is rocketed. You still have to wait for months. And if you start to negotiate the price, the installer will instantly drop your inquiry. He has no reason to start a negotiation on the product and labor work cost and price. So it's really an issue thinking about, let's say, installing 1 million units in Germany. The market is not saturated. The demand is not the issue. And the price level is not the issue. It's really finding people which are qualified in a sufficient way to guarantee that the work is well done and that the installation is well finished in a way that it does not require ongoing after-sales services.
Thank you. Sebastian, Bashir, would you like to add something?
Yeah, in terms of production, if I can put things into perspective, basically BDR Group produce every year more than 1 million boilers. So it means that in terms of production, we are able to produce for mass market. We also have been able during the COVID crisis to increase by 30% our production capability during the COVID crisis. So that's basically our job to be able to scale up our production. So we are ready and we are quite resilient for this. So I think it's not a problem on production. So that's my response to the question, basically.
I want to agree just with Norbert that the lack of willing installers in Germany has been a really big challenge for us also.
Okay, thank you. One question for Norbert. Does Boostit have a heat metering partner to share the output, thus to split the investment cost?
We have not a heat. I read the question. I'm not sure if I understand it. So we come with an integrated heat metering, but it's not, let's say, gauged and is not allowed to use it for third-party sub-metering. So you can do it within a family-owned home where two, let's say, family members have different apartments, and you can use our technology to do your own, let's say, sub billing. But by law, it needs to be a different system, which needs to be external to the heat source. And therefore, if this is a question, no, or only, let's say, for family, foods, and friends. But if it's a question about someone who is doing, let's say, running a joint business model, it's also no. And we do not really see it yet because our, let's say, target market are smaller homes, 1, 2, 3, 4 family homes, where heat metering is not really taking off. So there are very few in this segment of the market which are asking for professional submetering.
Okay, thank you. Now I would like to pose a question to Josephine. So if you can provide, let's say, a policy linkage, if you see, so a possible link between the current discussion on climate and energy policy with the Sun Horizon project.
Yes, well, I see different aspects that are very important. First of all, so I mentioned that there is this energy system integration strategy of the European Commission. So projects like this, where we really show the link between heat pumps and how they are integrated with other different solutions to offer, the best application for different cases. I think these are really key, to show how crucial a heat pump is in integrating the energy system further. So that's very important. And it's always good to have these concrete examples when we speak to policymakers and to show this. Also, as mentioned at the beginning of the webinar today, so this project is aimed at large-scale demonstration projects to reduce technical barriers, to reduce market barriers, and this, of course, contributes to reducing system costs. And we know that, in many countries, this cost is still a barrier. So this project can definitely help. And also the smart functioning aspect. So this is also important because, again, this can contribute to the cost aspect when flexibility is rewarded. This can trigger end-use demand, so that's important as well. And then in the last presentation, I think the business model of ESCOs, it really deserves much more attention also from a policy perspective. So this is definitely helpful, to show also to policymakers how this works, and that this should be more incentivized in the different member states to, again, take away a lot of the, a lot of the work for the clients that is then taken over by these ESCO business models. So these new business models should be put much more in the picture. So, yeah.
Thank you very much. Now, since we are approaching the closing phase of this online workshop, I would like to ask to the entire panel if you have some specific takeaway message that you would like to share, or if you would like to add something from your presentation, or maybe I missed some of the questions that you would like to quickly reply. So I ask you if you want to add something. This is the moment before we close the online workshop. So I see no reaction. So so I think we're good. So I really would like to thank all the participants for being here today and attending our online workshop. As you saw, all the speakers added their email at the end of each presentation, so you have their personal contact. So if you want to further engage with them, you can send them an email. I'm sure they are more than happy to reply. And as I said at the beginning of the workshop, you will receive all the presentations and the video of the recorded session in 2 days. And you will also find the material on Sun Horizon website and social media. So stay tuned, follow us on social media, and thank you again to the panel and participants for being here today. I will now officially close this session. Thank you very much and have a nice day.
Thank you.